How's it going, guys? This is Andrew, and this is going to be a tutorial on plotting the Bode diagram in Python using Jupyter Notebook, and this is for MBB 410 students at the University of Pretoria studying mechanical engineering. Let me just quickly launch Jupyter Notebook. Here we go. So first we want to import the first few things. So numpy is np, matplotlib.pyplot is plt, control as ct, and we want poly1d. We don't need the rest of these. So first we define our function, and we define it as gs here. So gs is going to be our open loop transfer function, and note that sys is going to be our closed loop transfer function. That'll come into play just now. Okay, I use the Magic Qt5. I prefer that. It opens it up in a new window and it's neater. So there's two ways of plotting the Bode diagram. There's this simple short code, these two lines here, or this actually single line of code, ct.bode. We're plotting the open loop transfer function gs. We say db equals true and hz equals false. This makes the y-axis of the gain plot in decibels and the x-axis in radians per seconds and not hertz. Then pt.grid just gives it a grid, and also if you leave out pt.grid, you're going to get this. Wait, let me just run this quickly. You're going to get this bunch of arrays and numbers, and you'll get there's your Bode diagram. But if you do say plt.grid and you plot it, then there's your Bode diagram and those numbers disappear. So that plt.grid is quite cool because it removes those numbers. That's the first way of plotting the Bode diagram. Very simple, very quick. The only thing is I know that it does cause some issues, or there's some sort of limitation to it, which I can't quite remember, but it does have issues. That's why I prefer to use this. This is relatively foolproof. This is a much longer code, but luckily you don't have to remember it if you're a student at Tux. So if you're studying Mech Eng at Tux and you're doing MBB, you've got access to, during all exams and tests, you've got access to Dorf figure 8.42. So this notebook has the code for plotting the Bode diagram. So we go to 842. And we copy and paste this first cell, as well as firstly we delete that, and we delete this MATLAB dot because that's going to change things. And then the other thing we copy and paste is going to be this set of code here. Copy and paste straight into your thing. Then we're going to change this to gs, which we defined here as gs, which is the open loop transfer function, and we're also going to change these two to 0 and these two to 180. So I just want to show you a quick trick that I've actually only learned recently. But if you click here and you're holding control and then you click again, you can edit in two places at once, and you can do this as many times, 5, 6, 7 different places. So those we want as zeros, and we click away. Then you hold control and you click there, and we want these to be negative 180. Okay, and you click away to get rid of it. Sorted. Okay, but we copy and paste this, and I've changed those already in this notebook. So here it is. Here you can see I've changed the controller as to control, the control.matlab to control, and I've changed gs should be somewhere here. Where's gs? Oh, I've done sys, so let's say gs. Okay, there's gs, and we've now changed it to gs, so that's the open loop transfer function. These two we want as 0. Okay, fantastic. So shift enter, and that will plot your Bode diagram. Cool. So now we want to discuss what is phase margin, what is gain margin, and what is bandwidth frequency. Note that these two you find when plotting the Bode diagram of the open loop transfer function, and the bandwidth frequency we find from plotting the closed loop transfer function, the Bode diagram of the closed loop transfer function. Okay, so phase margin and gain margin. Shift enter. Okay, so phase margin is where the gain plot crosses over 0. We find the frequency by zooming in and checking what the x value is here at the bottom left there, so it's 0.187 roughly. And we use that frequency and we go down to this graph and we find the value in phase in degrees at that frequency. So let's go there and we do this and say roughly, let's say that was the frequency. Our y value would be negative 92.11 or 12, whatever. So you say 180 minus this value, so it's going to be, this is your 180 line, that's why we changed it over here from 140. So you're going to say 180 minus whatever that was, 90, and that's going to be your phase margin. This distance here is your phase margin, and this distance is measured at the frequency where the phase graph crosses over 0. So you find that frequency, find the phase margin here. Then the gain margin is the exact same thing but in reverse. So we find where 180 crosses the phase graph, we find that frequency, we come up and we find this distance here at that frequency. Remember that x is the frequency, this is the gain, and that's the phase. Cool. So that's gain margin and phase margin. Let's close that up. Now, what is bandwidth frequency? So bandwidth frequency, first of all, we need to replot the Bode diagram of the closed loop system. So let's take G of S and replace it with sys, which we defined here as G of S with a feedback, closed loop transfer function. And let's plot that guy there. So you can see straight away that the Bode diagram is different. And notice on the gain plot that at very low frequencies the DC gain is 0, or the magnitude plot goes to 0 at low frequencies. So this isn't always 0, this can be some other value, but in this for this transfer function it is 0. So to measure the bandwidth, we're going to find whatever this DC gain is minus 3 decibels and draw a line across the whole thing. So in this case it's 0, so it's going to be 0 minus 3 is minus 3, and let's go and draw that minus 3 in there. Control backspace minus 3, click away and shift enter. Okay, so now where this crosses, let's zoom in here. Can you see that it doesn't cross at 0? This line is not at 0 anymore, it's crossing at negative 3 decibels. So we go here and we find the frequency, which is the x value, and that's 0.196. And that is our bandwidth, or our bandwidth frequency. Okay, and that's basically it. So the other thing is, like I said, this can sometimes not be 0. So let's say, for instance, it's negative 10. The DC gain there is negative 10. Then it will be negative 10 minus 3, which is negative 13. You draw a line at negative 13 and see where the gain plot crosses. And that frequency would be your bandwidth. And that's the basics for the Bode diagram. I highly suggest you go watch the Brian Douglas videos on plotting the Bode diagram and the phase lead compensator using the Bode diagram. His videos are brilliant. So he explains everything and what the Bode diagram actually is, and yeah, so this is just the basics on how to draw it using Python 3 in Jupyter Notebook. Cool. I hope this helps, and yeah, cheers.